Good day, friends. In the last video, we learned how to apply the idea of pseudo force. We had a cart block system, and the cart had an acceleration, and the block was resting on the surface of the cart, stationary relative to that cart. And we found an expression for the frictional force acting on the block. Today too, we restrict the application of the idea of pseudo force to the condition that the object remains stationary relative to the non-inertial frame of reference, and the non-inertial frame of reference comes here today in the form of an elevator. Let this be an elevator, and in it a man of mass m stands on the floor of the elevator. The elevator has an acceleration a directed upward. Now let's assume that any vector directed upward is positive and any vector directed downward is negative. Now let's analyze the different forces acting on this man in this non-inertial frame of reference. The first force is the force of gravity. And this force of gravity, F grav, is equal to minus mass of the man multiplied by the magnitude of the acceleration due to the Earth's gravity, and this is g. The negative sign indicates that the force of gravity is directed downward. The second force is the force of the normal force exerted on the man by the floor of the elevator, and this is F normal. And the man experiences a pseudo force in this non-inertial frame of reference, and we know that the pseudo force experienced by any object is the mass of the object, is the negative mass of the object multiplied by the acceleration of the non-inertial frame of reference. Thus, the pseudo force experienced by this man is equal to F pseudo is equal to negative mass of the man multiplied by the acceleration of the elevator. Now, let's analyze whether the man has any acceleration relative to this non-inertial frame of reference in the form of the elevator or not. The man stands stationary, so the man has no acceleration relative to this non-inertial frame of reference, and so the net force acting on this man in this non-inertial frame of reference is 0. Thus we write the net force F net is equal to F grav plus F normal plus F pseudo is equal to 0. In place of F grav, we write minus mg plus F normal plus, in place of F pseudo, we write minus ma is equal to 0. And thus we get the expression for the normal force exerted on the man by the floor of the elevator, and it's given by F normal is equal to m multiplied by the sum of the gravitational acceleration and the acceleration of the elevator. If the man stands on a weight machine he will see that his apparent weight is greater than his real weight mg, and if the elevator has an acceleration of magnitude a directed downward, then the sign of the pseudo force will just change, and finally we'll get the expression as F normal is equal to m g minus a, and the man will see that his apparent weight is less than his real weight. If the elevator moves upward or downward with uniform velocity, then this acceleration will be 0, and then the man will see that his apparent weight is equal to his real weight. This is all about the elevator problems. In the next video, we'll come up with more examples. Thank you.